Okay, exam 2, fall 24, projectile motion first, have a ball that goes up, comes back down again, tell you that the angle is 30 degrees and that V naught is equal to 18 meters per second. I give you the mass, but that's not important here. And I want to know several things. What is the speed of the ball at the top of the trajectory? Well, at the top of the trajectory, the only speed is the velocity in the x direction. Let's go ahead and find actually that initial velocity in the x direction. That's going to be V naught cosine of 30. That is going to be 18 cosine 30. Which is equal to 15.6. We'll go ahead and find our V naught y2 because we're going to need it. That's going to be V naught sine of 30, or 18 sine of 30, which is 9.00. So for answer A, Vx at the top, or actually I'm just looking for the speed of the ball, so I can just get rid of the x, but the only velocity at the top of the trajectory is in the x direction. So that's going to be equal to v naught x, which is equal to vx. All those things are equal at the top of the trajectory, which is 15.6 meters per second. So that's the answer for part A. For part B, what is the maximum horizontal range? So a couple things we need to do there is first find the total time, and to find the total time we say that Vy at the top is equal to 0, and that's equal to V naught y plus AY t, and this is going to be t top. I'm just trying to find the time that the object is in the air, and this will give us half of that time. So 0 is equal to 9 minus 10 meters per second squared times t top. So that means that t top is equal to 0.9 seconds. So the total time, t total, is going to be twice t top, excuse me, twice t top, which is equal to 1.8 seconds. So that's the total time. Then if I want to know the maximum range, I'll just say x is equal to vx times t total. That's going to be Vx, which is 15.6 times 1.80 seconds. Let's see, that is 28.1 meters. So that's the answer to part B, 28.1. And then for part C, I want to know what is the speed of the ball at t equal 0.5 seconds. So at t equal 0.5 seconds, let's see, it's going to be roughly right about here before it reaches the top. There are two components to that vector. One is in the x direction, and that's going to have a magnitude of 15.6 meters per second. And then the other one is in the y direction. That's going to be Vy. Let's just find Vy first. That's going to be V naught y plus Ayt. V naught y is 9 plus negative 10 times my t, which was 0.5. That's 9 minus 5. That's 4 meters per second. And then to find the speed of that object at that point, so now I have two vectors. One is 4.00, one is 15.6. So to find the speed at that point, it's going to be the square root 4.00 squared plus 15.6 squared. I get 16.1. So that's the answer to part C. Was that all? A, B, and C? Yeah. So here, I want to know, I have this block on an inclined plane. It's being pulled up with a force of 210 newtons. I want to know what is the normal force, the acceleration of the block if there's no friction, and then what is the acceleration if there is friction. So let's just first draw our coordinate system, just like that. And now I'll draw my forces. I have a weight acting in this direction, and then later I'll have a frictional force. I'm not going to draw it right now. And then I have a normal force acting in that direction, and then there's my upward force. Um, so I'm going to redraw this and resolve those vectors. By the way, this angle right here is 60 degrees. So I have my normal force, I have that force F, and then I have FW cosine or sine of 60, excuse me, and then FW cosine of 60. I'm going to leave off our frictional force for now. What is the normal force? I want to find the normal force. I say the sum of the forces in the y direction. That's going to be Fn minus Fw sine of 60. That's equal to 0, so Fn is equal to Fw sine of 60. Now Fw, I'll go and write it over here since this has a mass of 10 kilograms times 10 meters per second squared. That's equal to 100 newtons. So my normal force is equal to 100 newtons times the sine of 60, which is equal to 87 newtons. Yeah, with two sig figs. So that's my normal force. That's the first part, 87 newtons. And then for the second part, assuming that no friction acts on the block, what is the acceleration on the block? So here I have to do the sum of the forces in the x direction. That's going to be F minus Fw cosine 60. And that's equal to max. And I'm looking for ax in this case. What is the acceleration? So I have a 210, that's my force, minus Fw cosine 60, that's going to be 100 times the cosine of 60, which is equal to 50 newtons, is equal to m, that's 10, times ax. This should be 50.0, excuse me. So that's 210 minus 50, what's that? 160. So AX is equal to 160 divided by 10, which is 16 meters per second squared. Yeah, that's right. So that's part B. And now if I assume that I have this kinetic frictional force, now that frictional force is going to act down and in that direction. In that direction, I can calculate what that Fk is. It's going to be equal to mu k times the normal force. I already know the normal force is 87, and so that means that this is equal to 0.1 times 87 newtons, or 8.7 newtons. So now I have this additional force of 8.7 newtons. So for part C, redo this section, except now I have this frictional force, F minus Fw cosine 60 minus Fk is equal, oops, sorry, not 0, is equal to max. So I already have all these values, 210 minus 50 minus 8.7 is equal to 10 times ax, and I solve that for ax. I get 15 meters per second squared, which is less than what I saw up here for part B. Makes sense, right? Because it now has friction, so it should slow down just a bit. Right, so those are those three parts. Here, I want to know the magnitude and direction of these two vectors. First step is just find ax, ay, bx, by. So let's see, I want to know what ax is. That's going to be 12 cosine of 30. That's equal to 10.4. I'll just say 10 newtons. And then ay is going to be 12 sine of 30. That's equal to 6. And then I can do the same for bx and by. Bx is going to be 0. And then by is going to be, oh, excuse me, no, I'm sorry, not 0. Let's write the magnitudes of these vectors down first, then we'll need to go back and make sure our signs are right. So I have 24 cosine of 60, that's equal to 12 newtons, and then by is going to be 24 sine of 60, which is equal to 21 newtons. Okay, so look at these. I put them in bold actually for a reason. The vector A is 30 degrees above the negative x-axis, so the vector A is right there. And the vector B is 60 degrees below the positive x-axis, so that's vector B. So let's just keep in mind then that vector A has a negative x component, because it's along this axis, and a positive y component, whereas Bx has a positive x component and a negative y component. All right, so A's x and y components are there and there. That's AX, AY. BX is right there, and then BY is right there. So the signs are really important. Um, so I have a negative there and a negative there. Now the next step is to find Rx is equal to AX plus BX. That's going to be 12, negative 10 plus 12, which is equal to 2 newtons. See, I guess that would just be no zero point 0, just 2. And then Ry is going to be AY plus BY, which is 6 minus 21, which is negative 15 newtons. And now to find the magnitude, I'll do the square root of Rx squared plus Ry squared. It's the square root of 4 plus 15 squared, 225. Yeah, so that is 15. It's actually, I'm going to write it as 15.1. I know I'm keeping too many sig figs there, but just so we recognize that it's bigger than the y component. And then also theta, I would accept 15, by the way. Theta is equal to the inverse tan of ry over rx. That's 15 over 2, which is 82 degrees. Now I need to qualify that. So if I draw the x and y components of r, I have a positive x component and a negative y component. So that means that it's 82 degrees below the positive x-axis. Some other answers that would have been appropriate include negative 82 degrees. The negative denotes a clockwise direction from the positive x-axis, or 360 minus 82, which is 278 degrees. 278 degrees, or you could say 278 from the positive x. Okay, so those are the free response. Let's do the multiple choice. You launch a projectile in the horizontal direction, platform that's 125 meters tall, so y is negative 125 meters. X says it lands 30 meters away. What is the initial velocity? I want to know what v naught is. And by the way, that's going to also be equal to vx. Uh, First thing I'm going to do is find the time. I'm dropping 125 meters. So I know that y is equal to v naught yt plus 1 half ayt squared, but v naught y is 0 because it's horizontal. So I have negative 125 equals 1 half a negative 10 times t squared. So t is equal to 5 seconds, 5.0 seconds. Um, so now that I know that, I can say that x is equal to vx times t. And so to find the initial velocity, which is vx, I'm just saying x over t, right? The initial velocity is the same as vx because all of that velocity is in the same direction. And now I can find that that's just x over t. X is 30 meters, t is 5 seconds, so B is the right answer. You kick a ball with initial speed at this angle from the positive x-axis. What is the speed of the ball when t is equal to 2.0 seconds? So I have this object that goes up and comes back down again at t equal 2 seconds. I don't know if it's there or there, really where it is. We'll figure that out. But I know that if it's there, for example, that the velocities have two components. One of those is just going to be equal to v naught x, which is going to be 40 cosine of 60, which is equal to 20. And then I have to find the other, which is, I'll say that Vy, that's going to be, so this one is V naught x, and then this one is going to be Vy. That's going to be equal to V naught y plus Ay times t. And since the time is given, this is relatively straightforward. V naught y is going to be 40 sine of 60 plus negative 10 times 2. I get 14.6 meters per second. What that tells us is that I am on this side of the trajectory. I'm not on the other side because if I did, the y velocity would be downward. But I found it to be positive, so that means I haven't yet crested at the top of the trajectory. Now, final step is to find the speed. That's just going to be 20 squared plus 14.6 squared. I get 24.7 or 25 meters per second. All right, which of these represents the x component of the velocity? Remember, the x, as this object travels, the x component of the velocity remains same throughout. So B. Uh, from the same height, one ball is dropped and another ball is fired. So one just goes straight down and another goes off to the side. Which of these statements is true? Both balls have the same acceleration. Yes, they have ax equal to 0 and ay equals negative 10. Fired ball has a greater speed. Yes, that's true, because it has this extra Vx. The drop ball requires the same amount of time to reach the bottom as the fired ball. Yes, that's true. We did that demo in class, so that's true. And then that it requires less time. Well, that's the opposite, so that's not true. So it's A for 4. All right, object is fired from ground level and returns to ground level. Which of these happens to the magnitude of the vertical velocity? So I have this object that goes up. Remember, it starts out with a big vertical velocity that gets smaller, goes to 0, and then it increases in the negative direction. So the magnitude, it decreases, and then it increases. But, the magnitude is one of the key words there, that it decreases in the positive direction, increases in the negative direction. Which has the longest hang time. That would be A because it has a bigger y displacement. Vector A lies in the xy plane. It has a positive x component and a negative y component. So I'm somewhere in this fourth quadrant right here. Um, the magnitude of the x component is bigger than the magnitude of the y component. So the x component is big, the y component small, so the vector is right there. Now that vector is going to lie somewhere between this line, which bisects these two. Remember, this is, what is this, 270 and 360. That means this dashed line is 315. So it's somewhere between those two angles, which is A. All right, this vector has a magnitude of 12 and a y component equal to 6 meters. I want to know what is the angle. That's the y component. Well, I know that ay equals a sine theta. So sine theta equals ay over a, or 6 over 12. And that angle is the inverse sine of a half. That's going to be 30 degrees. Vector A is 10 units, vector B is 5 units in the negative y direction. I want to know 2A plus B, so I'd have 10 units and 10 units, those are both in the positive y direction, and then 5 units in the negative y direction, so I'd have 5 units there. This is 10, 10, 5. So the resultant is this vector, which is 15 units in the positive y direction. What is 2A minus B? Let's do a similar thing. There's A, there's 2A, and then minus B is B, but in the opposite direction. So the result is D. Person is in an elevator holding this mass. You exert a force. That means you're exerting a force to hold it up. I don't know if it's accelerating or not. That might come up. We'll see. All right, so the force is dependent only on the mass of the block. No. In fact, I'm probably going to add some text here about it accelerating. Yeah, I'll add something here about it accelerating. That is, it can be accelerating, but not necessarily. So if it is accelerating, if it's going up, accelerating upwards, then that force is bigger than the weight. If it's accelerating downward, that force is smaller than the weight. So it's not dependent just on the mass of the block. It's dependent upon the acceleration. I could say that the sum of the forces in the y direction is equal to F minus Fw equals MAY. So it's dependent not only on the weight of the block, but also on the acceleration. The negative acceleration means the elevator is moving downward. Okay, not necessarily. Like it can be moving with a velocity that's upward, and if it's slowing, then that means it has negative acceleration. So that's not true either. If it accelerates downward, F is smaller than the weight of the block. Yes. If it moves up at a constant velocity, that means that A is equal to 0, then yes, the force is equal to the weight of the block. So it looks like 3 and 4. D is the right answer for 11. Card is on a horizontal frictionless table. Once the card has been pushed and released, what will happen to it? It will continue at a constant velocity. That is with A equals 0, but velocity will be constant forever. In contrast, Aristotle believed that objects have a natural state, which is at rest. All right, let's say which of these equations are correct. Let's just write in all the forces. So here is Fn. This is Fw cosine of 60. And here's Fw sine of 60. I'm just resolving that weight vector. It's the frictional, there is a frictional force. It's moving up the inclined plane, so the frictional force is in that direction. Okay, those are all the forces that are acting on it. Let's see which of these are correct. All right, this one's not correct because Fn should be equal to that force, so this should be sine. F minus Fw cosine 60. Yeah, this one looks right. It's just saying this force right here is equal to the sum of these forces, or is equal to the max. Fk is equal to mu times Fw sine 60. Yeah, that's just a restating of that, but I know that Fn is equal to that force, so yeah, that one's correct. And Ay is equal to 0. On an inclined plane, Ay will always be equal to 0 as long as we have our y-axis, running perpendicular to the plane. So that would be A. Oh, what is the air resistance acting on this object? We don't usually consider air resistance, but here you just think of it as friction, that it's a frictional force. It's slowing down because normally this would not accelerate at 9 meters per second squared. It would accelerate at 10 meters per second squared. So that means that this object has a weight acting upon it, and it also has another resistive force, air resistance in this case. And I want to know what is that force. So the acceleration is equal to minus 9.0. So I just say F minus Fw equals max. F is equal, it's F minus, 100 newtons equals 10 times negative 9. So I get F is equal to 100 minus 90, which is equal to 10 newtons. Okay, this is the hardest page. Let's apply a tension force of 10 newtons on a block of 3 kilograms. There's the coefficient of friction. What is the acceleration? So we need to know what is this kinetic friction. Here I know that my normal force is equal to the weight. Normal force is here, weight is here. So that's equal to 30 newtons. So Fk is equal to mu k times the normal force, which is 0.1 times 30, or 3 newtons. So I have this force is 3 newtons. That means that the sum of the forces in the x direction is going to be 10 minus 3. I guess that would just be 7 newtons, but 7 newtons, and now that's equal to max. So ax is equal to 7 newtons divided by the mass, which is 3 kilograms, which is 2.3 p. Okay, this was a Newton's second law with some kinematics thrown in. First, I want to know the acceleration. A is equal to F over m. I'm applying a force of 15 newtons, and the mass is 5 kilograms. That means my acceleration is 3 meters per second squared. What is the displacement? Well, x is equal to v naught t. It's initially at rest, so that term goes away, and I get 1/2 of a, which is times 3 times 3 is 24. Okay, I have a mass of 10 kilograms. Sits on this table. The coefficient of static friction is 0.4. And I want to know what horizontal force is required to push the block. Well, that horizontal force has to overcome Fs. Fs is going to be equal to mu times the normal force. But look, the normal force here, because it's horizontal and there are no other forces, will be equal to the weight, which is 100 newtons. So it's 0.4. Let me just write that down. So the weight here, which is equal to the normal force, is equal to 100 newtons. That's 10 times the gravitation. 0.4 times 100. Number 19. All right, so I have an acceleration that is in this direction at 5 meters per second squared. And I want to know what is this force that is causing the frictional force, which will have the acceleration be as such. Because notice here that if it was just this force, I would be accelerating that mass at 10 meters per second squared. But I'm only accelerating it at 5 meters per second squared. So I want to figure out what that is, that I have this additional frictional force. So first, let's figure out the frictional force. We'll find that with the sum of the forces in the x direction. That's 20 minus F is equal to 2 kilograms times the acceleration, which is 5. So it's 10. That means that F is equal to 10 newtons. So this force is 10 newtons. Okay, so the frictional force is 10 newtons. Now, what normal force would give me that frictional force? So let's look at the y forces. I'm going to draw them over here. So I have Ft, I have F, I have this force that I'm pushing down with, and then in addition to that, I have the force weight, and then that's going to be equal to the force normal. So if you look at the sum of the force in the y direction was equal to 0, that's Fn minus F minus Fw equals 0. So um, I know that Fn, I know, let's do this off to the side. I know that the frictional force is equal to mu times the normal force. And so since that's 10 newtons and mu is 0.1 times the normal force, that means that the normal force is equal to 100 newtons. So I have 100 minus F minus the weight, which is 20 newtons, has to equal to 0. That means that F, the force that I'm pushing down on this with, has to equal 80 newtons. So A is the right direction. That is a tough problem, but you've worked this problem before, so I know that it gave some of y'all difficulty, but it is a problem that you've seen before. All right, let's look at this last one. This, apart from the inclined plane, this might have been the more difficult of all of them. I have this object with these forces that are acting on it. I have my force weight. I have a frictional force in this direction and a normal force. And then I have this extra force. I'm going to go and resolve it. This is 30 cosine of 30. And then this is 30 sine of 30. This is equal to 15 newtons. I'm going to do this 30 cosine 30 as well. That's 26 newtons. Okay, F weight is 150 newtons. I'm sorry, I put Fn over here. This should not be Fn, this should be the frictional force, Fk, because it is accelerating. Okay, so let's, I don't need to redraw this. I want to figure out what Fk is, but since Fk is equal to mu k times the normal force, then I need to figure out what is the normal force. So let's first find the normal force. Say the sum of the forces in the y direction is equal to 0. That's 15 plus the normal force is equal to 150. That means that the normal force, or rather minus 150, excuse me, 15 plus Fn minus 150, that's all equal to 0. So Fn is equal to 150 minus 15, which is 135 newtons. That means that Fk is equal to mu k times Fn, which is 13.5 newtons. So I have this force over here that's resisting the motion with 13.5 newtons. So to find the acceleration, let's say the sum of the forces in the x direction is equal to max. That's going to be 26 minus 13.5 is equal to the mass, which is 15 times ax.